Let's go over the answers to the momentum and impulse practice worksheet. A compact car with a mass of 725 kilograms is moving at 31.9 meters per second towards the east. Sketch the moving car. So here's the moving car. It's going to the east, so I drew an arrow going forwards or to the right. They want to know the momentum. So we use the equation that's got momentum equals mass times velocity. They gave us the mass and they gave us the velocity, so that steers us towards selecting the correct equation. M times V gives us a momentum of 23,127.5, and the units are kilograms meters per second. And we included the direction. You could say east or forwards or to the right. A second car with a mass of 2,175 kilograms has the same momentum. Find its velocity. So same formula. We know momentum because it has the same as the car in the previous problem. They give us the car's mass right there in the problem, and we're solving for V. So velocity equals 10.6 meters per second. A bowling ball is rolling down an alley with a velocity of 2 meters per second. Here it is, going forwards or to the right. For each impulse, A and B, find the resulting speed and direction of the motion of the ball. So in this case, let's pay careful attention to what information they've given us. They've given us mass, and they've given us velocity. And when we read further, we know they've given us a force and a time. We have an equation that has mass, velocity, force, and time in it. So half the battle here is selecting the proper equation, and we gave you a hint here for this first one. But remember, you know which formula to use because of the givens that they've provided. They tell us the force, it's 5 newtons. They tell us it's for 1 second. We know the mass of the ball is 7. And remember what delta V is. It's change in velocity, and change in is always final minus initial. We don't know what the final velocity is, but they tell us the initial velocity. It's 2 meters per second. So in this case, it's 5 times 1 is 5, and then we have to distribute this 7. And when we solve for V, it's 2.71 meters per second. And the answer is positive, so we know it's continuing to go to the right. It's going faster than what it originally was, so this impulse was pushing to the right. Or this force, we should say, was pushing to the right. A force of negative 5 newtons is applied for 1 second. That negative 5 tells us that the force is going to be applied going to the left. So negative 5 for 1 second, the mass is the same, and the initial velocity is the same. We're solving for final velocity again. The answer is still positive, but now it's slower. It started with 2 meters per second. Someone pushed it to the left. That slowed it down, and now it's got a velocity of only 1.29 meters per second. When you jump from a height to the ground, you let your legs bend at the knees when they hit the floor. Explain why you do this in terms of physics. Let me just read the answer to you. The impulse, that's the delta P, that you experience is the same regardless of how you land. You got that? So it doesn't matter if you bend your knees or not. This delta P will go from some value to 0, no matter how you land. So you'll have some type of momentum change. But if you bend your knees, you take a longer time to stop. Longer time results in a smaller force. So the reason why you bend your knees is to increase the time and decrease the force. A 0.174 kilogram softball is pitched horizontally at 26 meters per second. The ball moves in the opposite direction at 38 meters per second after being hit by the bat. So it says calculate momentum before and after being hit. Draw arrows to show the direction of the momentum. Look what they give you. They give you mass and velocity. So use this equation. Mass times velocity. The momentum is 4.5 kilograms meters per second. It's a positive value, so we say the momentum is going to the right or going forwards. This time, after being hit, the velocity is in the opposite direction. So it's negative 38 meters per second. So that's where we get this negative 38. So now our momentum is negative. That means it's to the left. Now, same set of givens, they're just more questions. So what is the change in momentum? We have to use the numbers we calculated from the previous problem. We have an equation for change in momentum. It's change in momentum equals final momentum minus initial momentum. So go back and check. Final momentum, negative 6.6. Initial momentum, 4.5. So it's final minus initial. This came from the previous problem. So the change in momentum is negative 11.1 kilograms meters per second. What is the impulse delivered to the bat? Well, here's where you have to remember your vocabulary. Another name for impulse is change in momentum. So the impulse is simply the same as change in momentum, which you calculated above. So it's essentially asking you the same question twice. The bat and the ball are in contact for 0.0008 seconds. What is the force of the bat on the ball? So they're asking for force, so use the equation that has force in it. We know how much time was given, and also we know the impulse or the change in momentum. So we know delta P, we know T, we're solving for F. When you solve for F, you discover there is a force of negative 13,875 newtons.